Today we're going to talk about the binomial distribution. Binomial distribution occurs when an event is either can or cannot happen. We call these a Bernoulli trial. It's kind of like flipping a coin. You have two options. You could have heads or you could have tails. If we were looking at the probability of, say, getting a disease, perhaps you have a 25% chance. All right, so let's suppose that we know that there is a 32% chance that you are going to win a game. Now, out of 5 games, we want to find the probability of winning exactly 3 of them. Given again that you have this 32% chance of winning any single game. So now, a couple things we want to figure out. First of all, what is our probability? Probability is 0.32. That's our probability of success. Well, if there's a probability of success, then we also have a probability of failure. Think about it. That's going to be 1 minus our probability of success, so 1 minus p, and that will be 0.68. The other information you need to get is your n. The n is the number of trials that we're going to run. In this case, n equals 5. If it were 6 games, n would be 6, but we chose 5 here. Now, looking at the binomial formula, the probability of our x being 3 is equal to n x p to the x 1 minus p to the n minus x. One of the things you want to be careful of is just trying to memorize a formula and plug it in. When you go to take your test, you're going to have numerous formulas in front of you. And you have to truly understand the pieces of the formula to know better how to use it. So in this case, our n represents a total number of trials. X represents the number of successes we're expecting to get out of those trials. We want to figure out the probability of exactly 3 successes. So our probability of a chance of success is 0.32. Now it makes sense that since we're going to have 3 successes, this 0.32 is going to occur 3 times, so we're going to raise it to the 3rd power. But if we have 3 successes, that means that we're going to have n minus x, which is 5 minus 3, 2 non-successes, or 2 failures. So it also makes sense that you're going to have 0.68 raised to the 2nd power. Now let's carefully think about what each of these pieces mean for a second. This represents the number of ways to get 3 out of 5. What does that mean exactly? Well, we could win the first 3 games and lose the last 2, or we could win the first 2 and the 4th game, or we could win the first 2 and the 5th game. We could win the 2nd, 3rd, or 4th game. These are all the different ways that we could get 3 successes out of 5. So instead of trying to figure out how each of them occur, we actually have a formula that will help us do that. So if you look at your formula sheet, you will see that 5 choose 3 is 5 factorial divided by 3 factorial, 2 factorial. So that's 5, 4, 3, 2, 1 divided by 3, 2, 1, 2, 1. Notice this is really easy to calculate. A lot can cancel away, and that number becomes 10. Or you can actually use the combination key on your calculator. It often looks like this. There's different variables, n and x, n and r, but you can go ahead and pause the video for a minute and try your calculator and see that you also get the 10. Just be very careful. There's another key on your calculator. That's a P. You don't want to make a mistake and use that particular key. So now, let's go back to our problem. We now know that this is 10. Remember, 3 of these 5 are going to be successes and 2 are going to be failures. So we're going to just plug that all into our calculator. And everybody do that right now. Get your calculator out. Take 10.32 squared. .68 and you get 1515. So if we were to create a chart, what we have right now is, to complete the entire distribution, you would repeat this process for each value of x. Well, some of them are pretty easy. Consider for a second 0. So what does that exactly mean as we plug in our formula? Out of 5 games, we're going to get none of them correct. So there is no chance of success and all 5 chances of failure. Well, there's only one way that can happen. And 0.68, everybody check your calculator, to the 5th power comes out to 0.1454. Now again, I will leave it to you to fill in the rest of this table.